Happy day, YouTube. My name is John, and this is my channel, The Intermancer. In the last episode that was long, too long, I started working on describing an experiment life cycle in my context document so that I can work with Claude, and Sonnet 4.5 has come out and it's pretty nice. I can work with Claude to evaluate an experiment, and I'm going to continue that effort. My commitment to this project is to do everything out in the open in front of everybody, even the boring parts. And I know that this is a boring part, but this also has been interesting for me because doing it this way has given me a chance to recognize how important it is. I've kind of gone back to design first approach, which for a lot of the code that I've done in the past, especially professionally, has been more of a code first approach and then come back, do tests later, do documentation later, do everything later, just get the code out the door. And this context first approach is forcing me to think about what it is I'm building and how I'm building it in detail, because I'm describing all of that before I do any of the building. So that has been interesting. And so let's continue now. One thing after I finish this little section I'm on right now, which is method implementations, one thing I realize is that I'm going to go method implementations for scored organism. It's been a couple days since I did this. I was editing the last video. I'll finish the scored organism repository description, and then I am going to go back because I want to expose those life cycle methods that are in evaluator implementation. I want to put those in the interface because I want them to be available to other things, and I know that any other experiment implementations that I might do later are going to need those same default sections. So with that being said, let's get back to this scored organism repository method implementations. Since one thing I've realized is that I've been thinking a lot about how to do this in-memory scored organism repository because it needs to have some indexing. And since I'm not doing this using a database where I would build an index, database guys, they spend a lot of time thinking about how to maintain indexes, how to keep them balanced, and definitely I haven't spent that kind of time on it. So I know that whatever I implement is going to be a little naive, but it's also gotten me to think about how an index is its own data structure and how certain operations are going to be more expensive than other operations. Specifically, adding and deleting operations are going to be more expensive in the approach that I've decided to follow. So let's go ahead and start describing that. Since the in-memory implementation will need to maintain a sorted list of scored organisms so that we can pull organisms so that we can search by score, search efficiently, search by score, as well as a map of scored organisms so that they can be looked up by ID. Let's see, the scored organism. Let's go ahead and just copy this section. Simply uses the map of scored organisms for lookup. I don't need to keep the descriptions of what the methods do that I provided above. All I need to do is talk about expected implementation here. Adds scored organism to the map and the list. Let's see, I know that I went to Claude and it gave me some good advice about using a sorted list. So I'm going to add that to the description here. Scored organism. Okay. So the fact that scored organisms implements comparable will allow the collection's binary search to work. So I'm probably going to end up with code that looks a lot like what Claude has already described. So I'm going to use, so I'm going to use this code to guide my description. Insertion point. Collections dot binary search to find the insertion point in the list of ranked. List of ranked scored organisms. delete. Deletes the first, looks up the scored organism using the ID, looks up the scored organism from the map using the ID, using the score property, looks up the scored organism from the list, then deletes the scored organism from both the map and the ranked list. First, determine the subset of the list to choose from by simple proportion of this is done by simply looking at the top since the list is sorted, simply use the count size of the list to determine how many are, to determine the cutoff, then use a random number to choose a scored organism from the subset. And it's going to do basically the same thing for the get random from bottom percent. Of the top scoring organisms of the bottom scoring organisms. Okay, that's good for now. Okay, so that is the scored organism repository. Now let's go back up to the Actually, I'm going to update here, see if my my Markdown reader is going to start working again. My Markdown renderer. Here we go. How do I close this? There we go. That's a tab. Okay, I was doing the repo first. Evaluator. Experiment. Okay, let's go ahead and put all of these methods in the interface. Parents. Okay. I've made quite a few changes at this point. So now I am going to push up to Git. I'm going to update my project and I'm going to start talking with Claude. Commit and push. Projects. F, update the sync here. It's retrieving. Done there. Dated the description of the experiment class, turning it into an interface with more methods. Have also added an implementation of added a description of the implementation. Further, I have added a description of scored organism and a repository for scored organisms. We will start with the scored organism and the repo. Look It's experimentation. Experimentation.md and generate scored organism.java along since it is we don't need any tests for scored organism. All right, let's see what it does. Record class. Okay. Now this transient thing about the organism, I probably didn't need to say much about that because the scored organism is just going to have a pointer towards the organism. So I don't really need to worry too much about that. Let's go ahead and update the repo accordingly, or the description of the repo. Experiment. Go all the way to the top. The organism that was scored. Okay, that's fine. That being said, now let's go see what it generated. ID scored implements. It's got okay. It's got the scored organism ID. We're gonna add some more creators. Do I want to bother with Lombok? Because Lombok would give me all of the constructors that I need. I'm not going to bother with Lombok. Oh, record. What is a record? That is new to me in Java. When was record introduced to Java? What is it? As soon as you see something you are not familiar with, be sure to look it up. March 2020, okay. Designed to be transparent, immutable data. Okay. private final field. So where did it declare the organism transient? Okay. A canonical constructor that initializes all fields. Public equals. Okay, interesting. So let's copy that. Let's go in here. Now, where does this go in the code? Organism. Where did we do evaluator? Evaluate. New record. Scored organism. Okay. Experiment. Okay, we don't need this in this constructor. Get ID. UUID, so it gives it a new UUID there. All right, I'll take it. Public accessor methods named after the field, not get XXX. Okay. I'll take that, sure. That's easy, look at that. Okay. Now generate the interface for the scored organism repository. Okay, we'll change that. Change that now in the description about the passed in not having an ID. So let's go ahead and go to there. Saves a scored organism for later retrieval. Okay, copy that. We'll put it in the same package, or yeah, package as scored organism. Scored organism repository. Okay, must have fat fingered that. Scored organism Repository. Why is it not adding? Interface. Scored. Organism. Repository.java. Okay, this is weird. This might be where I go out and get IntelliJ. I've been thinking I need to get IntelliJ. And I think this is where I'm going to do it. Yeah. Okay. So I'm hitting a little bit of a weird snag. I'm going to use this as a point to stop my video. And when I come back, I will hopefully be on IntelliJ. Thank you for your time.